Okay, so let's continue.
Okay.
So we have relational operations. This is very important because sometimes, yeah. Did you find it? Oh, you need it for my system.
No, this one.
Yeah, yes, that's right. But do you have the files?
No.
You have to. You can put them on desktop. Right. Okay. So because when you execute things in computer, often you have some condition. Under some, for instance, if x is greater than 3, you may want to do something. When x is less than 3, you may want to do something else. So you need to be able to distinguish between these two. So, in fact, this is quite important. So this expression, 40 less than 40, this is either true or false. So you tell me, is this true or false? It's false. So I should be able to do Shift-Enter, and it gives me false. Now, here we have, all right, here we have 40 equals 40. This also is a relation. Okay. So this is asking, is 40 equal to 40? Now be careful, because it's very easy to just do something like this. Sorry. If I do this one, it's going to say error. 40 equals 40. Why? Because what this is saying is, take the number 40 and set it equal to the number 40. But you can't change the number 40. Okay? Alright, so 40 is 40, you can't change it. So that's what it says, cannot assign to literal. This 40 here is a fixed value. You can't change it. I can do something like this. I can say x equals 40. That gives the value 40 to x. It's an assignment statement. Right? This is fine. No problem. X equals 40. But I can't say 40 equals 40. In fact, I can do something like this. I can say, all right, is that an error?
No.
Okay. Well, it's false.
False.
It's not an error. It's false. Okay. But of course, if I try to do this, that's an error. Okay. So false is not error. False just means it's not true. Whoops, sorry, I missed. Right. Now, how about this one? What's that going to be? That's true. All right. Now, you can convert false and true to 0 and 1. Okay. Here it says, when arithmetic operations are performed on logical values, the logical values convert to numbers. False becomes 0 and true becomes 1. Okay. All right. So, let me ask you this. If I use this rule, what will this code give me? What's the result going to be? That's yeah, I heard that. It's 3. It's 3. This is 1. This is 1. This is 1. This is 0. Okay. All right, now. Okay, it says, this code gives the sign of the number that is contained in the variable y. Let's think about this. If y is positive, what will this give me? If y is positive. If y is positive, this is 0. And this is 1. So I get 0 plus 1, which is 1. All right, so I can put y equals 1. I can put y equals 40 here. That gives me the sign of 40. Okay. And then, but what about if y is negative? Gives me 1 minus 1, right? Because then this is true. That becomes a 1. I get minus 1. Right? So that gives me the sign. Now there is also a sign function in Python, but this gives me the sign. All right, so here it says, when used with arithmetic operations, logical operations have lower precedence. That means the logical is done last. Okay, so what's the result of this going to be? What's the result? Remember, the logical operation is done last. It's not 0. Yeah, so the question, so it's going to do the plus first. Right? So this gives me 64 divided by 8, that gives me 8. Remember, this is integer divide. Okay? 8 is going to take 8 plus 5 is 13. Is 13 equal to 8? False. Not 0, but, sorry, but false. But false.
Okay. Okay, we will take this first. We take this first.
Yes.
Add it to this.
Yes.
And then execute it with this.
Yes. Sorry. All right. But then what about this one? What is this going to give me? No, not 0. 6. Then it gives me 6. Okay. So I recommend that you try some of these exercises at home. If we want some mathematical functions, in Python, the mathematical functions are contained in libraries. And there are several libraries. There's one library called math. But this is not the library we use so often. The better library is called NumPy. So I'll start out with math. So import math, what that will do is that will give me all of the mathematical functions that are in math. So here are some mathematical functions that are in math. The constant e is math.e. Constant pi, math.pi. The function square root, math.square root.
What of dir?
Oh, dir will tell me all of the functions in math. So if I execute this one, you can see all of the mathematical functions. Arc cosine, arc hyperbolic cosine, arc sine, arc hyperbolic sine, and so on. Now here you have arctangent and arctangent 2. If you know arctangent is not a good function because two different angles have the same arctangent. So arctangent 2 is a better function. So you can see there are many functions here, including factorial function, floor function, and so on. Many, many functions. GCD function, and so on. Floor? Floor, that's... All right, so let's see. Let's see. You can type print, floor. Well, let's try math.py. Let's see what it gives me. All right, so I don't want to show the directory again. Okay, I made a mistake. It's math.floor because it's in the mathematics library. So if it's in the mathematics library, I need to indicate that it's in the mathematics library. How about this one? Why?
Okay. Int is 0.71 like that.
Yeah.
So maybe it's recognizing the integer value.
It's the integer value.
And pi is
Yes. Yes, that's right.
Floor is what?
Okay. All right, we'll try this.
Huh?
What's the result?
57.
57. Yeah.
That is good. So if you don't bring that number, look at that one. Look at that number 3. It will bring the integer out of the
Yeah.
decimal number.
No, what I'm saying is that what does floor mean? What does it mean?
This is a floor down here.
This floor. This floor.
Yeah.
So, and so why is it taking?
Because it's the floor. It's the floor.
And that's what the mathematical function is called. Floor is the same as greatest integer.
When you add the decimal number, look at it.
If you, in fact, if you look on the internet, floor function, if you look on the internet, you'll see floor and ceiling functions.
Floor and ceiling function.
Yeah. Yeah. So maybe they don't call it this in physics, but you can look on the internet and see. Yeah. Yeah. In fact, I believe that I think it's CEIL. I think it's like. Ceiling, floor, and ceiling, yes. Yeah. Ceiling is up, floor is down. I'm surprised you don't know this. This is standard name for these functions.
Okay, it's approximating. Yes, nearest integer.
No, it's not approximation. Floor does not.
What about this one? What's the ceiling?
It's not 0. 0. It takes
Yes. Yeah. Yeah. And notice there's no decimal point. So this is an integer value. It's an integer value. Now this is interesting. I wonder if this is going to say, is this going to be true or false? Oh, sorry. Is this going to be true? All right, it is true. Okay. All right, so as I mentioned, if you want to get math functions, you need to put the math dot in front. Okay. If you want to understand a math function, you can always type help. So help will often give you some information. All right, now, to always type math is too long. So you can give it an alias. Alias is like a short name. For instance, my son's name is Joseph. We call him Joe. It's the same person, right? Okay. So here it says import math as MM. MM is now the alias. So instead of typing math, I can just type MM. So this will give me the same ideas. So what will this give me when I print this? What will this print me for me if I do this? So what is cosine pi over 2? Pi over 3. 1/2. Okay. But let's see what happens. All right. Now you see the 1 here. This is numerical error. Right? You always need to be careful about this. So for instance, if I do this, it's going to give me false because of numerical error. So you need to be careful about this. So it's a problem. This is a problem with programming. You have to be careful. You can get some numerical error. All right, so let's move on. Okay, so I'm going to move on down here. Okay. Yes. Okay, sure.
Like in between, so
Yes.
without the two different.
Yes, that's right. Two calculations. Yes.
Not having
Yes. I see. I have two different. Here, let me. Yeah, I didn't update it, so yeah. So yeah. All right. So again, I recommend you do some of these exercises. All right. So we've already seen before that this is an assignment statement. You can't put a number on the left, and you always put the variable on the left and the value on the right. Right? If I do this statement is fine. Now, if I execute this statement, it won't show anything. Does that mean there's an error? The answer is no. It doesn't show me anything because I didn't ask for anything. Jesus said, "You shall not have because you do not ask." Okay? So you need to ask. Ask and you shall receive. But if I do something like this, this is wrong. You always need the variable on the left and the value on the right. All right, so that's basic assignment statement. So we've looked at this already. I think I can skip these things. All right, now one thing that also may confuse people. Let's look at this code. Here I say x equals 4, y equals x star star 0.5. So what's that going to be? That's 2. But it's going to be decimal. So it's going to be 2 point, and there may be some round off error. I don't know. We'll see. Okay. So here it says the original value of y should be 2. All right. Then it says y equals x plus 5.005. Okay. That's going to be 3. Okay. It says the new value of y is 3. Now, the new value erases the old value. It's gone. It's completely gone. You cannot recover it. It's completely erased. Okay. So the new value covers over the old value, and the old value is gone. Variable names can be very long. So it's a good idea to make your variable name describe the quantity. So it's not like mathematics where you have to use x or p or w. You can use some name that describes your quantity. Right. So for instance, if I want to find the area of a box, if I want to find the volume of this, there's base side 1, base side 2, and the height. I want to multiply these three together. So I can define 3 variables. Base side 1, base side 2, and height. I multiply base side 1, base side 2, that gives me the base area. And then the volume is going to be base area times height. Your variable name can have this underscore. Okay. But if I try to do something like this, that's not allowed, because it thinks it's a minus sign. You also cannot do things like this, because this means something else. A space also is not good. What, sorry? Underscore is fine. Underscore is fine. And I believe you cannot begin a variable with a number. You can put the number in the variable, but you cannot begin the variable with a number. Okay. We can try. Okay. Let's see. So suppose I say 1 time equals 3. All right. See, it doesn't like this. Because as soon as you put a number, it thinks that we want to give it a number. So I can't do this, but I could do time 1, like this. No problem. No problem. All right, so here, let's see. All right, so these are not so important. So this is variable assignment. Let's go down. All right, now here's another thing that you cannot do in mathematics. Here I say x equals 5, then I say x equals x plus 1. All right. In computers, you do this all the time. This is called incrementing. What does it mean? It means increase the value of x by 1. This means replace the left-hand side with the right-hand side. So this, okay. So this is x is 5. This is going to give me what? 6. Then this will give me what? Yeah. So give me 25. So my final result should be 25. So we call this updating. Oops, sorry. Okay, sorry. All right. So, all right. But here, also you need to be careful. Variables must be assigned a value before they can be used. So for instance, if I execute this, now Python tells you very clearly what's wrong. It says name error. It tells you where, and it says var1 is not defined. So if you get an error like this, look back in your code, it means that you have never given a value to the variable. All right, so we'll skip these, and here's some more updating. Okay. Okay. All right, so for instance, I could do something like this. N equals 0, I start with n equals 0. And now I can execute this one. I'm in this cell now. Now remember, if I press Control Enter, it will execute the cell and stay in the same cell. So let's see what happens. I can do that. If I do it again, you see? It will take the value of n that it has and add 1. Now I can go here and do something like this. Then what happens? It goes up by 2. Right. Now, you can see that when if you're doing a program, you don't want to sit at your computer and do this for 100 times. You want the computer to do this for you. All right, that's when we're going to have something called for loop. For loop will do this for you multiple times. Right. We'll see for loop very shortly. But for loop, there are two very important statements in computer. No matter what language you have, there's for and there's if. These are the two basic statements in programming. For repeats it. If will give you, you can change, you can tell your computer to do different things. Yeah.
Now here we have defined n.
Yes.
Somewhere in one cell at a time.
That's right.
That's the reason why we're executing this.
Yes.
What if I don't want n to retain that name again?
If you don't want it to.
I don't want this n.
Yes.
To be the first n I define. The value I get to n. Now I don't want that n to retain that name again. I want to define another n entirely.
Well, I mean.
If I say n, now is it, let's say before we have defined n to be equal to 2.
Right.
Now, I need another n. I want to define my n now.
Well, let me ask you, if you're doing an equation in physics, if you have an equation in physics, do you ever have two different n's in the same equation? Okay, it's the same here. You can't have two different n's in the same equation. You can have n1 and n2, but you can't have two different n's.
I get you right. What I'm saying is this. Now, I have defined n somewhere.
Okay, sure.
And it's 2. Now, I didn't want that n. I am bringing a new equation.
Okay.
And that equation also have n.
Okay.
I don't want to change. I don't want to change.
I
I,
see.
still want to assign n. I want to use
All right.
n as my variable.
Okay.
Now,
All right.
what do I do so that it terminates the usage of the first n and now begin to execute with my new n I want to define?
Well, I can just tell you that if you have a new n and you assign a new value, it will forget the old one. It just forgets it. But you cannot recover the old value. You can change, but you cannot recover. So you would have to save that in another name. But it can only remember one value for one variable. It can't remember more than one value for one variable. So. Okay. All right. So I mentioned we're going to see a for loop very shortly. So here's your for loop. Okay. All right. So here's your for loop. So this looks very complicated, but most of this is common. Okay. All right. So here we have n equals 0. Right. This is the initial value. Okay. All right. So the following for loop will repeat 24 times. So note the colon at the end of the statement. This says for m in range 24. All right, for now, we should just understand that to mean that this is going to repeat 24 times. Okay. All right, now, this is also important. The lines below are indented, which means they are within the loop. They will be repeated. So these lines will be repeated 24 times. Both of them. So what's going to happen? The first time through the loop, n will increase by 1, and it will print the value. Then it goes back, and will increase by 1 again, and it will print the value. 24 times. Okay. And then finally, it says the following line is not indented, it's not repeated. So this one will print once. So let's see what happens. So you can see initial value, and it goes 24 times. And then it says finished. Whoops, sorry. All right, now, suppose I change this and I do something like this. What's going to happen now? Okay. All right, let's see what happens. Okay. I started with 0, so maybe it would be better to start with a 1. Let me start with a 1. Then you can get these powers. All right, so you see it's getting very big. Now, suppose I want, sorry, so that's just to 24. Suppose I want to go up here. This is going to be long, long, long print. I just want the final value. What do I do? I don't want to print every one. I just want to print the final one. I take this, and I move it there. Remember what I said, that the lines that are indented are repeated. It's only the lines that are indented that are repeated. This is not indented, so it's not repeated. Okay, so if I do this, all right. So this is going to be on the test. You need to remember this number. So please remember it, please. Right. Now I'll show this in a minute. But in fact, suppose I do this. What do you think will happen? What do you think will happen? Python can do this. I could do another one, but I think I don't. You can go. This is exact answer. This is the exact answer. No, I don't want to stay here too long. But sorry? Third one. Okay. Well, then, all right. If you want to do that, we would need an if statement. So we'll show that later. I would have to, well, I can show you now. I can say, so you want to see the third one, right? So I can say, if m equals 3. Okay. All right, so I made a mistake. Do you see the mistake I made? What do I need to do here? This is a mistake that you should know. 2 equals. Because I'm testing if they're equal or not. So that's how you can do that. So as I said, the if and the loop are the 2 important statements.
Did you start to?
Okay, here, let me take this. I don't want this so big, so let me make it small again. I'm going to remove this back down to 100. That's not so big. All right, so you can imagine how to create a function that does factorial. You know, factorial is 1 times 2 times 3 times 4. Okay, so here, all right, so maybe I shouldn't show you all right, so here I have 2. Here's what I start. N equals 1, factorial value equals 1. Let n be the factorial I want to find. Suppose I want to find 100 factorial. What should I do? What's my next statement? I need a 4. Now remember how I put it in here. This is for m in range of 100. Suppose I want to find the factorial of this value. Let's say 57. I want to find 57 factorial. So this is going to be 4m in range of what? Right? To find 57 factorial, I'm going to have to multiply 57 times, right? So how many times do I want to do the loop? 57. But 57 is my value of n. So here I'm going to say all right. Now I have to multiply my factorial value each time. Remember, factorial is 1 times 2 times 3 times 4 times 5. So my factorial value equals factorial value times what? Okay. Well, n is always 57. All right, so that would be 57 times 57 times 57 times 50. What I want is 1 times 2 times 3 times 4 times 5 times 6. So let me define another, this is one way I can do it. Let me define another value. Oops, sorry, my mistake. Okay. So I can multiply by x, but then the next time I want to multiply by the next x. So what's going to happen? The first time I multiply by 1. Second time, then I add 1 to x. So x becomes 2. The second time I multiply by 2. Then x becomes 3. Next time I multiply by 3, then x becomes 4. And I continue to do this. So let's do print. And see if we can follow this. Okay. All right, so I don't want to put 57 here. I want to put n here. Because then I can change the value. All right, so let's just try a simple one. Let's try n equals 3. So what did it do? First time through, well, as I said, first time through x was 1. It said factorial value equals factorial value times 1. It's fine. Second time through, I'm sorry, after that it changed x to 2. Right? Then second time through it multiplied factorial value by 2. So that gave me the 2. Next time it multiplied factorial value by 3. So I can do this. I can go to a larger value. So it's giving me the different factorial value up to 50. Yeah.
Line 3.
Yes.
Factorial value.
Yes.
equals to 1.
Yes.
Why do you assign 1 to the factorial value?
What value should I assign? What value should I assign?
What values should be assigned?
I don't know why.
Okay. Suppose I remove this. Suppose I remove this. If I remove this. Oh, all right. The problem is that factorial value was defined previously. But here, let me see. How can I do this? I think it's clear. So just a moment. Sorry. Sorry. Let me start a new notebook. All right, here, let me copy this. Sorry. Okay. All right. So I'll run this code. Okay. Do you see what's going to happen? Is this going to work? It's not been defined. Yeah. Yeah. You have to give it a starting value before you can multiply.
So in this,
Yes.
the factorial value is it a function or a variable?
No, it's a variable.
Okay.
Factorial value is a variable. Yes, that's right. It's a long variable. It's the name of a variable. As I said, it's good to name variables that have a description of what they mean. I could have just called it f or something, but I want to make it clear that this is the value that I'm looking for. I don't know if you understand yet, but it's okay. It will take some time. Okay. So I think I just did the same thing here. All right, so this, okay. All right, so here. All right, so we can skip this one. You can read this yourself and do the exercises yourself. I just want to give you the outline. So I recommend that you do go back and look at this again yourself. Because it's intended to help you do by yourself. And we have some things here like Newton's method. This is very useful mathematically. If you want to find the root of a function, you use Newton's method. Right. So this is not just for games. You can do some serious mathematics with this. Okay, so let me go to the next one. So I'm going to go File. Oh, by the way, let me show you that here's my original web page. You can see that this is in green. That means that this notebook is running. Well, it says also, this notebook is running. This is the one I'm using now. So I can close this, but it's still running. I closed my page, but it's still running. If I wanted to stop running, I can go here and check this, And then I can say shutdown. So I'm finished with number 4. Let me go to number 5. Let me go to number 4. So it's coming. All right. So data types and data structures. So one example of this is I mentioned that Python sees integers and floating point numbers as different types of data. I also mentioned strings. This is another type of data. In this chapter, the important type of data that we're going to look at is list. List is a very important type of data in Python. All right, so let's go to the introduction. Okay. All right, so here it says, so for instance, here I have a equals 4 times 5, b equals 4 times 0.5. Instead of this, let me do 4 times 5. Okay. Now when I execute this code, what did I do? Where's my mistake? That's strange. Oh, I see where my mistake is. Do you see my mistake? No, that's not the problem. Sometimes when it looks like there's a mistake, it may not be on the same line, it's on the previous line. In this case, the mistake is not on this line, it's on the previous line. So do you see the mistake? The mistake is in line, I didn't close the bracket. This is missing. All right, so what does this mean? I printed type A. Type A as an integer. 4 times 5. 4 times 5 point is called float. Because if I put the 5 point, then Python knows this is a decimal number. Okay. Now here it says try for yourself. What is the type of minus 1 to the power 1/2? So let's try. Oh, I had to do print, sorry. Complex. Now, I should mention also, if you try to do this, if I try to do this, error. Because the math functions are not in basic Python. I would have to do something like import, and then I can say this. All right. But in fact, this one also doesn't work because math cannot take the square root of negative numbers. So I would actually need to do something like this. And then I can use NumPy to do this. But as I mentioned, NumPy is more useful than NumPy. What happens? Now it still says something wrong. I'm surprised that this doesn't work. I'm surprised that this doesn't work. So I'll have to research it. I wonder if I do this. Okay. Let me try this. Okay. All right. So in fact, this time it works. All right. So the reason it didn't work was NumPy will take the square root of a complex number, but you need to tell that it's a complex number. NumPy knows that this is a complex number because 0j is the square root of -1. So NumPy knows that this is a complex number, and it will take the complex square root. So I'm sorry, that's a little bit complicated, but that's why it's important to understand types. because the type may change the result. Let me change this back. Actually, I want to, let me go ahead and make a copy. I'm going to make a copy of this so I don't change my original. I want to preserve my original file. It's coming. So there are basically three types of numbers: integers, floating point, and complex floating point. There are more types, but we won't talk about those today. The other types are used for other reasons. So I already mentioned how Factorial, you can create very large, you can do very large calculations. Here, let me remove I'm going to remove all the output. You can change the type of variables. This x, what type of variable is this? Float. Now if I change it to integer, it's going to take that number and it will take the integer part. But in fact, it's not the floor. This rounds towards 0. You see, if I tried this, all right, so let me import math. Import. If I do this, sorry, then let's call this z. Sorry, this should be math. Okay. So when it printed x, so I should say this. Right. So when I apply the floor function, it's -8. Because floor always goes down. Int always goes towards 0. So even if I did, so even if I did minus 7.1, it's still going to go, so I should, this one I shouldn't have. I said, so there's some difference between int and floor. All right, so we talked about the logical variables are called booleans, B-O-O-L. So, for instance, if I say print type of truth, we'll say boolean. All right, so let's go down. Okay, so more things about integers. More about floating point. Okay. More about floating point. Some exercises. Complex numbers. You can find the absolute value of a complex number, the imaginary part, the real part. You can multiply. You can find the conjugate of a complex number. Let me make sure this is working. Now, see, all right, so this, I should have said this. Square root of -1 is called 1j, not j. So if I do this, we'll say, I don't know what j is. But if I do 1j, it knows what 1j is. Python uses j. If you know that engineers use j instead of I. So they use j. So this will give me the absolute value and the imaginary part, the real part, and do some. Right. So So you can do many things with complex numbers. All right, so now we go to sequence. All right, the difference between sequence and a number is sequence has several items. The items have an index. The index goes in the square brackets. I should mention that in Python, square bracket is only for index. I remember seeing somebody, for instance, sometimes in mathematics, let's do this. I want to, I think it's this. For instance, sometimes in mathematics you will do something like this. 5 plus 4 minus 7. Sometimes people like to do square brackets if they're inside the round bracket. If you do this, you will get an error. Square bracket is only for index, not for doing some statement. Only for index. So you need to put round brackets. Okay, so I made a mistake. I think I forgot one of these. So that's fine. But that's a special use of square brackets. And we'll see some example of square brackets in a moment. Yeah, you need to. We'll see. All right. All right. I'm going to pass by strings. We've seen strings already. Strings are useful when you want to display your result, but it's not very useful for calculation. So I'm going to pass by strings. I want to get to matrix multiplication because I know you want matrix multiplication. So and I don't know how long my battery lasts. Okay, so here's lists. All right, so here's an example of lists. You see the square brackets, right? These are elements of the list. This list has 3 elements. Okay. So if I do this, it will give me these 3 elements. It performs this calculation, and that is now an element of this. Now, I could also do print example square bracket 1. So I need to do this. Now, what is that going to give me? All right, so somebody said 15. In fact, it gave me the second one.
Right. The first location is 0.
It starts at 0. Always need to remember that. It starts at 0. Okay. It starts at 0. If I want example of 0, so that's another, if you know MATLAB, that's the difference with MATLAB. The first index is 0. All right. So here I have a list of strings. Each element in the list is a string. Here I have a mixed list with some strings and some numbers. In fact, a list can have lists as elements. The first element of this list is a list. So if I do print mixed list square bracket 0, what do I get? I get apple orange. Because that's the first element in my list. Okay. Now, is this a copy or let me make a copy here? I don't know if this is a copy or not. So let me make sure it's a copy. It's coming. It's coming. Did I copy already? Yes. Okay. All right, never mind. So I'll just continue. Okay. All right, so now this is an empty list. Sometimes when you want to build a list one by one, you may want to start with an empty list. So this is quite possible. There's no problem with the empty list. It will give me no problem. All right, now, for instance, here's a list here. If I take index equals 3, and say this element equals A of index. Okay. So when I execute this code, what will I get? I want to execute this code. What will it print?
531.
It's going to print 531 because that's entry 3. Right. 0, 1, 2, 3. And if I want to, I can change this to 4. It will give me 300. Now, sometimes you want more than one element. You do it this way. If I want more than one element, I give the first index, and then a colon, and then what I call up to index. Okay, sorry. Now, what does up to index mean? Here I had my first index was 1, my up to index was 3. Element 1 we know is this one. Sorry. Now, element 4, this is element 1, 2, 3, 4. So you might think that this will give me 1, 2, 3, 4. Okay. In fact, it only gives me 3. Up to index is not included. So if I go 1 up to 4, it will give me 1, 2, 3, and not 4. Right? So if I go, for instance, if I go 0 up to 5, it's going to give me 0, 1, 2, 3, 4, and not 5. So that's another thing that you need to remember. Now, one thing that's interesting, I can put a -1 here. -1 means the last element. So if I want to start at element 2 and go up to the last element, I can do this. I'm surprised that it did that. It should go up to the last element, so I'm not sure why it did that. So I think maybe it works different for list than for array. Now, if I add two lists like this, 357 plus 246, all right, it does not add these as vectors. If you add two lists, it creates another list that has both. Okay. If you multiply a list, so here I add these two lists, I put them one after the other. If I multiply a list, what it does is it duplicates the list that many times. Okay. So I can multiply a list by an integer. Now I believe that if I try this, it's going to give me an error. You can only multiply a list by an integer. Because how can you add a list 5.3 times, right? So it has to be an integer. It has to be an integer. All right, range. It's very often useful to have a list of numbers 1, 2, 3, 4, 5, 6, 7. You don't want to have to type in 1, 2, 3 up to 1,000. So there's a special command called range. Range of 3 will give me 0, 1, 2. 3 is not included. So you can see this here. Okay. If I do this, range of 10 will start at 0 to 9. One way I remember this is range of 10 is a list of 10 numbers, but it starts at 0. So 10 numbers starts at 0, only goes up to 9.
Okay, question.
Yeah.
What if I want to add 10 to it and I use range?
Okay, very good. We'll get there. That's a good question. Maybe I can tell you now. So you want to start with 10 then?
Yes, I want to add 10 to it.
Okay. All right. If you want to add 10, then you can't use list, you need to use array. That's another data type. And that's in the next, you have to use array. With array, you can add values. Now, if I want a list that starts at 10, I can say range 10 up to 20. Now, this will start at 10 and go up to 20, but not including 20. Sorry? If you want...
0 to 10.
She's talking about what you said first.
What I said first? Well, yeah, that if I wanted to do this, just like this, up to 10, that would go up to 10. Yeah, yeah. So just remember, if you have range like this, 11 is the number of elements in your result, in your list. Now, another thing to remember is if you want this to be a list, you need to put the list command in front. If I just say this, this is something different. If I want it to be a list, I need to put list. Yes, it just says range, but it doesn't tell me what it is. Right. You can also, if you want to go by 2, you can add a third argument. This will start at 3. It will go up to 11, but not including 11. And it will skip by 2. 3, 5, 7, 9. 11 is not included. You can also go backwards. This one starts at 10, goes down to 0 by -1. So you can do many things with this.
Yeah, another question.
Yeah.
Can I set it in form of formula like n equals 1?
Well, you would not do that here. You can do that. I showed that before how you could do that. All right. So if you wanted to create a list 1 by 1, you could do something. If you wanted to do a program like that, let's say we'll say n equals 0, and I'll say for m. So I want to start with an empty list. So my list equals, for m equals, for m in range, maybe a range of 20, colon, and I can say n equals n plus 1, and I can say my list equals my list plus, and now I want to add another element. Now I can't do this. I have to do this. Because I'm adding my previous list to my next list. And then I can do print my list. And I print this at the end. So you can add 1 by 1. So remember, the plus for lists will add new elements. But you can only add a list to a list. As I said, if I take this off, it's going to give me an error. Now you can do this. You can say this. But this is interesting because what this will give me is empty. Why? Because what I did was my list is empty, and I just repeated the empty list many times. Okay? If I said my list is 0 and I did this, then no, it won't give me 0. It will give me something very, very long. I'm surprised it's not giving me anything. I think what's happening is it's taking too long to print. Memory error. Why? Because I took 0 and then I multiplied that. When I multiply by 1, it can be 0, 0. Then I multiply by 2, it's 0, 0, 0, 0. Then I multiply that by 3. So I have so many zeros, it has no memory. Yes. Okay, so I can do maybe I could do 5. Even that's too long.
And the end is not in
The end is fine. I'm surprised it's... there we go. Yes. Okay. right, so here's some exercise for lists. Okay. All right, I think I can skip this for today. Because as I said, I want to get to arrays. So I'll stop this. All right, so my array is here. So array is down here. And I'll make a copy. Now, arrays look very much like lists, but the best way to think about array is like a vector. You know when you add vectors, you get another vector. When you add arrays, you get another array the same size, just like adding vectors. You can multiply a vector by a scalar. Right? If I take 5 times the vector 2, 1, I'll get 10, 5. You can multiply arrays by a number, and you'll get another array. Yeah.
Can an array be a list?
Well, you can convert an array back to a list using the list command. You can also convert a list to an array. However, you can only convert a list of numbers to an array. If you have a list of strings, well, I think if you have a list of strings, it will convert the strings to numbers. And then it will make it an array. But arrays can only have numbers. Only have numbers. Okay. Array is like a vector.
Like a vector.
Yeah. I think that's the best way to think about it. Okay. But array belongs to NumPy. You need NumPy to do arrays. So you'll see here that at the beginning of every cell, I always import NumPy as NP. I should say that in each notebook, you only need to import once. So in each notebook, you only need to import once and then execute. Then it will remember. But I put in every cell because sometimes if I start my notebook and I execute a cell in the middle and I don't execute a cell before, then I might get an error. All right, so here we have a NumPy array. Okay, so here you can see it just looks like a vector here. All right, sorry, let me get rid of this here first. All right. Now, remember when we used range, we create a list. But if you want to create an array, you use a range. Now, it's not a range. It's a range. You see, there's not 2 R's. So it's easy to forget that. Okay. All right, now, the difference between range and a range is I can make range, with range, I need to use integers. With a range, I do not need to use integers. So for instance, I could go from this one here. Let me do a simple one first. I could go to 0.5 to 2. Okay. So what does it do? It starts at 0.5. It goes up by 1 until it reaches the top value, and then it stops. Now, if I wanted to include 2, I could do 2.1. If I do 2.1, it will 0.5, 1. No, I'm sorry, that's not going to work. The 2.6. Okay. There it goes 0.5, 1.5, 2.5, then it stops. Right? But if I put 2.5 here, it's not included. It will not include the last value. Now, if I want to go up by 0.5, I can put 0.5. That will give me 0.5, 1, 1.52, and so on. Okay. So this gives me evenly spaced numbers. Another way to create evenly spaced numbers is linspace. This is different syntax. What this does is the first number is the starting value, last number is the finishing value, And the 5 is the number of values. So this is going to give me 5 values. The first value is -3, last value is 3, and they have even spacing. Whoops, sorry. You see, each one is spaced by 1.5. Even spacing. This is very useful, for instance, if you're doing an integral. If you want to do a numerical integral, you need to divide the integral into equal parts. So that's what you can do there. You can create special arrays. Okay. Whoops, there's a mistake here. That should be a period. Sorry, excuse me. All right. So important numpy is NP. NP dot zeros 4 means I want an array with 4 zeros in it. NP dot ones of 6 means I want an array of ones with 6 ones in it. Suppose I want an array of 6s. Then I can do NP1s times 6. Remember, arrays are like vectors. So here, for instance, I can do NP1s 3 times 5.7 plus 4. So it takes the ones, multiplies all ones by 5.7, and then adds 4. So this is a good way to build vectors. All right. I don't know how long this is. All right. So we may go back to this next time. Let me go directly to matrix. All right. So far we've been talking about vector. A vector only has one dimension. Matrix, you know, has 2 dimensions. So the way you create a matrix is you make an array of arrays. So you create an array, and each element of the array is a row of your matrix. So let me see if I can go down there. Okay, here, I think the best way for me to find it is go to here and, all right, so here you can see, oops, sorry. All right, so from, sorry, let me change this because this is another syntax. Okay, I'm going to put NP. Okay. All right, so here we have an array of arrays, right? This, see, 2 square brackets. Why? Because this is the first element of the array. This is the second element of the array. You see, when this prints out, it will print 2 different rows. 2 different rows. Now here it says print array 2 day 1 2 1 2. What does that mean? That means I want row with index 1, column with index 2. So why did it give me 6? Because this one is row 0. The first row is row 0. The second row is row 1. The first column is column 0. The second column is column 1. Third column is column 2. This is row 1, column 2. The second row is row 1. And the third column is column 2. Okay. So I'm sorry, I can't change this. Right. But this is how you can find elements of your matrix. Now, you can also create arrays with more than 2 dimensions. You can have array of array of array. So you can have tensors, if you know what a tensor is. So you can create tensors. If I want a 2-dimensional array of all ones, I need to give 2 indices, not just 1. So for instance, so I made this mistake again. This should be, so you're sorry. So this should be np.1s. Okay. And then this should be np.1. Right. So this gives me an array of ones with 3 rows and 2 columns. All right, so let's do some matrix multiplication. So I have, let's say my matrix is equal to, let me do import numpy as np, and then just say matrix is equal to, let's just say, we'll call it np.ones. Let's make it 5 by 5. So I'll call this matrix 1. And then I'll do matrix 2 is equal to np.ones of, let's say, 3, 3, 5. Now, if you want to multiply matrices, so I just ran out. Okay, so if I want to multiply matrices, I have to do matrix 1 at sign. At sign is above the 2, and then matrix 2. So I can show you on my screen if you want. So it's matrix 1 at sign, matrix 2. All right, and it will multiply the two matrices together. So you put this in. Yes, that add is matrix multiplication.
Now, but here, you are saying all the elements should be 5 by 5. What
No. It's not all elements. No, it's 5 by 5. All the elements are 1.
Okay, now if I want to impute the element of the matrix.
All right, so let's go. So I'm going to go back to your paper. Let's go back to your paper. So I told you I wanted to go to your paper. I think I put it here. Oh no, I didn't put it there. I put it somewhere else. Oh, there it was. Okay, sorry.
The name is
It's this one. Here. All right. So I'll show you how you can do this. It's really not difficult. Oh, let me stop recording. Sorry.